But now what we have to do is we have to be able to put a motor on that. What motor are we going to put on it? They don't make a 55 horsepower motor, so we got to go to the next size bigger. And so we'll put a 60 horse motor on that. Now the interesting thing is, will it run at 60 horsepower if we got a 60 horse motor on it? No. It's going to run at 55.3 horsepower. It'll only draw 55.3 horsepower worth of energy. It's going to run pretty easy. It's going to have an easy load for the amount of capability. We're not using its full capability, and it'll get better motor life that way because of that. Because we're only making it pull this much. It's kind of like your car. You know, you might have 200 horsepower under the hood, but how often do you use it all? Not very often. It's there available, but you don't have to use it. Same with the motor. And you're saving energy. The less you use, the less energy you're absorbing, see? So you want it to run down, but you want to size your motor to fit the need of the system. The other thing we can find in here, what's its NPSH at that operating point? The net positive suction head. And that's required. The pump requires a certain amount of suction lift. And so we come in here and we look at our point, and it's somewhere between 10 and 15. That's a real tough one to read because that isn't linear, it's logarithmic in nature. You notice from 10 to 15 is a wide distance, and then from 15 to 20 it's a narrow distance. That tells you that this is logarithmic in nature. So we could say safely we know we have a 15 foot, and we could probably say maybe 13. And I'd say the NPSHR is approximately 13 feet on that particular pump. After you read a few thousand of these curves, you get pretty good at it. So it tells us that the pump is that much inefficient. So what we do is, to evaluate the NPSH available, that would equal sea level, which would be approximately 34 feet, minus the NPSHR, 13 feet. So our maximum potential lift in this case is only going to be 21 feet. So we only have 21 feet of lift available on this pump. The pump is this much inefficient, 13 feet inefficient. So I've lost that capability. We said the average is about 25 feet. This pump doesn't quite make the average. But that's how you deal with that NPSH. Now that 21 feet can be a combination of friction loss in the suction pipe, elevation from the water surface to the center of the pump, and then the vapor pressure evaluation along with the altitude above sea level. So, and it's a somewhat complicated process to calculate that out. But it's, you can do it out. A lot of companies kind of have it cookbooked. Look it up on a chart. Makes it pretty simple.